so kini sa sample is an example of internal standard. Okay, so a standard sample was prepared containing 10 ppm of an analyte and 15 ppm of an internal standard. Okay, so that means we have here an analyte, the analyte, okay. Change that to black. Okay. We have here an analyte and let's symbolize that as A. And internal standard. Internal standard. Let's symbolize that as I. So, ang analyte nga gibutang is 10 ppm, whereas ang internal standard is 15 ppm. Okay, so ang analyte class is the substance that you're interested in. So example, ang imong analyte is sodium. Ang internal standard ana will not be sodium. It will be a substance nga different sa sodium. And ang internal standard, ang qualification para mahimo ang internal standard will depend on the analyte. So it should have almost the same property as the analyte. Okay, so for example, ang sodium, you can use an internal standard nga potassium, okay? Because they have almost the same properties man. So, remember an analyte and an internal standard have different identities. Okay? So, ang reading niya is 0.155 units, whereas kini is 0.233 units, di ba? So, kini siya class, this is inside 1 volumetric flask. So, sud sa usa ka volumetric flask, gibutangan siya og 10 ppm nga analyte nya 15 ppm nga internal standard. So, both these kanang substances are present in this flask, and then girun siya sa instrument. That is, then the instrument gave this reading kining 0.155 and 0.233. Okay, so in another reading, in another flask, you now have the sample, ang imong sample containing the unknown. So it's still the analyte, di ba? But in this case, wa na kakabaw sa concentration. Okay? Because it's your sample naman that contains the analyte. Dili naman ay kining sa first nga flask, you prepared the analyte. Nagprepare ka og 10 ppm nga, for example, if your analyte is sodium, 10 ppm nga sodium nya imong gisodere. Kini, you have the sample and you wanna know how much sodium is present in the sample. And so, you don't know the concentration of the sodium, but you know that there is sodium because that's the sample. You're looking for sodium. You suspect that there is sodium in your sample. And so, the internal standard sa dere, internal standard is 15 ppm lang gihapon. And then, this gave you a reading of 0.274 sa sample and 0.198 units sa internal standard. Okay, so this is again in one flask, kining analyte og internal standard. Okay? So, meaning class, ang advantage pa di ay sa imong internal standard is that since ang imong analyte ug ang imong internal standard kay pareho man sila, di ba nga, ma-affect sa noise sa instrument, sa errors sa instrument, di ba? Because there are errors nga dili man jud di mo malikayan. Okay? So since both the analyte and the internal standard kay maapektuhan man sila sa errors o sa instrument noise. That means if you take the ratio of both, makancel pud apil ang noise, di ba, ang errors. So mas mo-accurate ang imuhang result. That's the advantage of internal standard. Okay, so back to the calculation. So that means ang kini nga reading, ang kining 0.155 nga reading must be the reading of this analyte, di ba? The reading of the brought about by the concentration of the analyte and a constant, di ba? Let's say it's constant A lang sad. Okay? And then kining 0.233 must be brought about by the concentration of the internal standard and of course the constant pod. Okay? Kasabot. So if you take the ratio of kini, ang reading atong i-denote as S ha, ang reading. So if you take the ratio of the reading of the analyte over the reading of the internal standard, that means it is equal to this value. Diba? So now, you're only left with this K. Diba? And if we take, since, diba, ang K, maapektuhan man po siya both, diba? Kay naapektuhan man siya, it's the sensitivity man of the instrument. So, since maapektuhan man po ang K, then we can denote that as K nga dako, CA over CI. Okay? So, we can transform this into A over SI is equal to KCA over CI. And you just take, if you want to know the value of K, you can transform this into SACI all over SICA equals K. So now you have the value of K. Okay? So the value of K will be SA is 0.155 U times CI, which is 15 ppm, right? All over ang SI, or the reading of the internal standard, is 0.233 U, and the reading, the concentration of the analyte is 10 ppm. 10 ppm, and that gives you a K value of, how much is that? So 0.998. Okay? So mao na tong K nga value. So we can use that here. So we can formulate the same equations. 274 is equal to KA CA 0.198 is equal to KICI. We can just directly substitute that in here. But in this case, ang ato ng unknown is this na, ang concentration of the analyte. So, from here, we can just use SACI is CI over SIK is equal to CA. Sakto ba akong pag-transpose? This is just algebra class ha. So that means ang imo nang i-substitute nga values is kini nang naadere sa second nga flask. Because in the first flask, ang kining nga sa flask nga 1, kining this part, you use that to calculate for K. Okay? So here ang SA is the reading of the analyte, which is 0.274 units, and then ang concentration sa imong internal standard is 15 ppm, and then ang imong reading sa internal standard is 0.198 units, and then the K value of 0.998, which is equal to, so, okay, 0.274 15 all over 8 20.80 20.80 or 20.8 milligrams per liter. Kay ppm man, di ba? ppm is also milligrams per liter, remember? Okay?